Okay, when you've done probability at GCSE and you had the probability of one event or another, it usually will have meant that you needed to add. Now, we need to be a little bit careful with this. Sometimes that works, sometimes it doesn't. Let's consider the probability of B or R, and I've told you what events B and R are over here. So the probability of being blue or red, okay, well, altogether, there are 5 tiles that are either blue or red, so the answer to this is 5/8. Okay. Now, if I look at the separate probabilities, the probability of being blue, there are 2 blue out of the 8, and the probability of being red, there are 3 reds out of the 8. So I do get the right answer if I do 2/8 plus 3/8. But now let's consider if I add in the event that S, the shape is a square. All right, and now let's consider the probability of being red or a square. Okay, probability of being red or a square is, well, the ones that are red or a square, we did this earlier. I've got a square here, and 2 more red ones. So there are 4 tiles. These ones here. These 4, but not the 4 at the top. 4 at the bottom are red or a square. So the probability of being red or a square is a half, or 4/8. The probability of being red is still 3/8. And of course the probability of being a square, I've got 2 squares out of the 8 tiles, so the probability of being a square is 2/8. So, but I can now see that if I add my 2 probabilities, if I add the probability of red to the probability of being a square, I will get 5/8, not the correct answer of 4/8 or a half. So what's gone wrong? Well, if I think about adding my 3/8, 1, 2, 3, to my 2/8, 1, 2, I see that I've counted this red square twice. The problem with adding events is when both events can happen together, because then the occasions when they can both happen will be counted twice. So the rule we actually need that will cover this case is to say the probability of R or S is the probability of R plus the probability of S, but then I need to remind myself that when R and S both happen, in this case just with this tile here, I will have counted that twice. So I need to subtract the probability of it being a red square, which is the probability of R and S, R and S. So this is the generalized rule for adding probabilities. Okay, we don't just add the 2 probabilities to get the OR event. To get the OR probability, we add the 2 basic probabilities, but then we have to take away the probability of them both happening. Okay, so in this case, this top one, where I did get the right answer by adding these probabilities, that was only correct because the probability of it being both blue and red at the same time is 0. Obviously, if it's red, it can't be blue. If it's blue, it can't be red. So therefore, these are non-overlapping categories. Here are my blues, here are my reds. There aren't any that are both blue and red, so I can add the probability of blue to the probability of being red. Okay, now when that happens, these are called exclusive events. So R and B are called mutually exclusive events. Okay, and in this particular case, it's obvious that red and blue are mutually exclusive categories because it can't be red and blue at the same time. But there are some other examples of things that just happen to be mutually exclusive. So in this particular case, the events B and S are mutually exclusive because here are my 2 blue shapes and neither of them happen to be squares. So my category of blue, those 2 there, and my category of squares, okay, don't happen to overlap. So the fact that the probability of being blue and a square is 0 is what makes B and S mutually exclusive. And because they're mutually exclusive, if I happen to know that, then in this particular rule here, for mutually exclusive events, then the AND event will have a probability of 0. B and S has a probability of 0. So the equivalent of this statement with B and S instead of R and S, this term would be 0. So I could get the right answer by doing the probability of blue plus the probability of being a square. It would be 2/8 for blue it would be 2/8 for being a square, and lo and behold, 4/8 is the correct probability. That only works because there are no blue squares in this set of tiles. So that's what exclusive events are, and it's how to find an OR probability using an addition, and we've met this formula here.